The Lake Erie Regional Grape Research and Extension Center manages a 40-acre vineyard with rolling topography that creates cold pockets, low-lying areas where temperatures drop significantly and can kill high-value grapevines overnight. Our solution is a wireless Bluetooth mesh sensor network deployed across the vineyard, continuously collecting temperature data at multiple points. That data is transmitted to a central Raspberry Pi hub, stored in a database, and made accessible through a local web interface, giving the vineyard operators precise, actionable temperature data exactly when they need it.
If you've got smart lights at home, those likely operate on a Bluetooth mesh network. Your lights all communicate together through passing messages from one to the other, things like their brightness or color. Together with other smart home devices, these make up your network. Similarly, we utilize a Bluetooth mesh network in the vineyard for the sake of temperature monitoring. Instead of lights, we have nodes which have sensors. Instead of passing their color data to your phone, we pass temperature measurements to a central database for future analysis.
At the heart of each sensor node is a U-Blox Sonora B206 microcontroller that communicates with DS18 B20 digital sensors that provide temperature data with 0.05 degrees Celsius accuracy. These nodes are powered by 19,000 mAh lithium clinal chloride batteries, giving the system an estimated lifespan of over 5 years. To handle the elements, we have packed electronics into IP68 rated UV stabilized polycarbonate enclosures that feature ePTFE pressure equalization vents to prevent internal condensation.
After connecting to the router, the user will have access to the web interface. Here the system status is shown. It will either show the suspend phase if the mesh is currently asleep, or a wake phase if it is relaying information back to the Raspberry Pi. Underneath is the cycle time, which is currently set to 15 minutes. At the bottom of the screen, the most recent node readings are displayed with the temperature and the timestamp for both the top and bottom of each node. For accessing the information, they can download a CSV right here. To access the admin page, they just enter their credentials and press login, in which the mesh is connected. The mesh cycle settings let the user tell the mesh how often the temperature readings must be taken, which is currently set to 15 minutes. The wake duration and firmware delay are also changeable. For node management, you can name nodes based on their base address. Here we have test node with the base address of 000E in hexadecimal. In order to clear the database on the Pi, you can just hit clear all data. And at the bottom is the system log, which tells the user what the Raspberry Pi is currently doing.